Today we're going to learn about the real number system. The materials you need for today are your interactive student notebook, a pencil, glue, 5 different colored pencils, pens, highlighters, or markers. Please do not use dry erase markers. Notes, which are located on the student table on the way in, and a sticky note for you to use for your exit ticket. I'll give you a second to collect up all your materials. Alright, so copy your learning objective on the top of page 21 in your interactive student notebook. The learning objective is, I will extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of real numbers. Now let's talk a little bit about our learning objective. What are the verbs here? Our verbs are extend. And what are we extending? Previous knowledge, which means some of the things that we are going over today you've already learned in previous grades. What previous knowledge? Sets and subsets of real numbers using a visual representation, which will be a Venn diagram, to describe relationships between numbers. So today we're going to be talking about how numbers are related to each other and how we can categorize them into different categories. So the categories of the real number system are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Natural numbers are counting numbers. So we can count 1, 2, 3, 4, 5, so on and so forth. So under the natural number tab in your notes, write the definition and give some examples of what a natural number is. Whole numbers are all of the counting numbers, and now we can also add in 0. So 0, 1, 2, 3, so on and so forth. 1,000, 1,000,000, 364 billion. All of those are whole numbers, including 0. So write the definition for whole numbers and write a few examples. It's very important that you write the number 0 out to the side. Now, as you go through your notes, I suggest that you write in a different color writing utensil. So if you got a pen or a pencil, color code each category with a different color. So you have 5 different colors to use. Whole numbers should be different from the natural numbers. They should be in different colors. Integers are all of the natural numbers and their opposites. So now we're including negative numbers and also 0. So as you can see, as we move up in our Venn diagram, we're including everything that was in the category previous. Again, this is natural numbers. Those are my counting numbers. 0, and then the opposites. So -3, -21, -35. Now I would have you note that integers cannot be decimals and fractions, ever. There is no decimal, no fraction that will ever be considered an integer. Our next category is rational numbers. This is one that is probably a little more difficult to decipher. Rational numbers are numbers that can be expressed as ratios. Another word for ratio is fraction, but as ratios of 2 integers. So any number that I can write as a fraction is considered a rational number. This set includes natural numbers, whole numbers, integers, terminating decimals. The word terminating means to end, so decimals that have an end, like 3.5, it stops at the 5, or 12.62, it stops at the 2. So any decimal that has an end is called a terminating decimal. And also repeating decimals are in this category. So if the decimal has the same pattern of numbers, it's considered a repeating decimal, like 3.66666 repeating, or 5.33333 repeating, or 11.727272. So any number that has a repeating pattern, the same pattern of numbers, also is considered a rational number. Here's some examples. I can write 2 as 2 over 1, 3 1/4 as 13 over 4, -0.25 is -25 over 100, 1/3 is 0.33333. That's an example of one of those repeating decimals. Can you write 16 as a ratio? Now try writing negative 0.25 as a ratio. A calculator could be a really big help. Remember, we learned on Tuesday how to use our calculator to convert from decimals to fractions. All right, let's pause for the cause. We're going to classify each of the following decimals as repeating, terminating, or neither. So draw a line under your learning objective in your interactive student notebook on page 21, and then number 1 through 10. And then decide for each one if you think it is a repeating decimal, a terminating decimal, or neither. Now, our last category is irrational numbers. Irrational numbers cannot be expressed as a ratio or a fraction of integers. In decimal form, they are numbers that go on forever without repeating a pattern. So crazy, kind of strange numbers that never repeat and they never terminate. For example, the square root of 2, pi, and 45.9492, so on, and so forth. Other examples of irrational numbers are square roots of non-perfect squares. So if it is not a perfect square, it is an irrational number. For example, the square root of 17. Also, pi is the most common irrational number.
Delicious.
So what is the square root of 17? What is another non-perfect square? So although we learned that pi is 3.14, this is actually what pi is equal to. And it keeps going on and on and on and on and on and on forever. So your real number system diagram should look something like that one. This is also on my website, and I have posted a picture on Instagram if you ever want to go back and refer to it. This is another diagram. That shows how these numbers are related to each other. Big hint, when classifying real numbers, always put numbers into simplest decimal form. So if you make your fractions decimals, it might be easier for you to recognize if they are rational, irrational, whole numbers, or whatever category they go in. It will be easier to recognize if you put them into simplest decimal form. All right, let's practice a little. In your interactive student notebook, write each number in the correct space in your Venn diagram. Use a pencil just in case you make a mistake. If you can't see these numbers really well, you can use the PowerPoint presentation that's in our OneNote class notebook. It's there also. And here's your exit ticket for today. It is by desk color. So if you are sitting at a pink desk, give an example of an integer that is not a whole number. If you are sitting at a green desk, give an example of a rational number that is not an integer. If you are sitting at an orange desk, give an example of an irrational number. And if you are sitting at a yellow desk, give an example of a whole number that is not a natural number.